taking a look at something like this one, I want to determine if the polygons are congruent. And I'm just going to do that by measuring. Remember, for two things to be congruent, their corresponding pieces also have to be congruent. So basically, I just have to look at this piece for piece and make sure all the angles of one match up to all the angles of another, and all the sides of one match up to all the sides of the other. And so I just start taking measurements of this thing. So as I look at this thing, I come over here and I'll measure something like angle D as 90 degrees. And when I go over to the other shape here, I want to match that up with something that I think looks the same. And it looks like that matches up with Z. So I'll check it, and yeah, they are the same, okay? The measure of angle C is 90 degrees when I measure it, and it looks like that matches up with Y, so I'll check angle Y, and that's also 90 degrees, okay? So that looks great. And then again, I'm going to have to spin this thing around and measure some of these other guys, so maybe I'll measure angle A next and say, oh, angle A is 90 degrees, and that matches angle W, which is 90 degrees, and then if I flip this thing around again, the measure of angle X over here is 90 degrees, and that matches the measure of angle B, which is 90 degrees. And so as I look at this from the perspective of angles, all the angles match up, all right? Every angle of one is congruent to the angles of the other. So A matched W, B matched X, so we're off to a good start, but now I have to do the same thing with the sides. And so as I check this, maybe I'll start with something like AD here. If I started with something like AD, looks like 4.9 centimeters when I look at the centimeter side. And so if I compare that to WZ, it looks like I also get 4.9 centimeters. And so side AD and side WZ matched up. That looks great. But I continue to do that. And if I suspect there's a side that doesn't match up, I want to jump to that one. So maybe I look at this and say, you know what? It looks like DC doesn't match ZY. So let's check it. So DC down here, once again, looks like a 4.9 centimeters. And if I match that up with a ZY, well, ZY looks like a 5.3 centimeters. And so right away, I've now found a side that doesn't match. I don't need to keep going. In order for these to be congruent, every piece would have to match up. And as soon as I find one piece that doesn't match, I know that the two polygons are not congruent, okay? Take a look at the next one. The next one, I've got some triangles here. And triangles, there are some shortcuts in terms of triangles, in terms of you not having to measure everything. But if you're in doubt, you just measure everything. So as I look at this, these are turned differently. So once again, make sure you match up the pieces that you think look the same. So like here, if I measure angle C as 90 degrees, well, I wouldn't come over here and measure angle W to compare it. I would look at angle Y because that's the one that looks like it might be the same. And when I look at that, they are the same. They're each 90 degrees. And so now if I were to look at angle W next, I would say, oh, angle W looks like 60 degrees, but I wouldn't compare that to angle B. I would compare it to angle A. I compare it to the one that looks like it could potentially be the same, okay? And so I come over here, angle A. Looks like, yes, that is also 60 degrees. And so let me just mark what I have so far. If I look at this, I measured this as 90, and this one matched up. And then this was 60, and this one matched up. And really, I don't actually need to measure the last angle because the angles inside a triangle add up to 180, which means just looking at this first triangle, this has to be 30 degrees to give me 180. Looking at just the second triangle, this has to be 30 degrees to give me 180. And so now I can see, without actually measuring them, that angle B and X match up, okay? I could use my protractor and check that, and I'll find that it works. Now I compare the sides. Down here, I look at these sides, and I say, okay, this longer leg looks like to be about 6.6. And so I got to compare that to the longer leg in the other triangle. So right here, I line it up. And yeah, it looks like 6.6 once again. So then maybe I jump over to the smallest side of this thing and say, all right, the smaller leg here looks to be about a 3.8. So I compare that over here to the smallest side once again. And when I compare it to the smallest side over here, it looks like if I can get it lined up, oh yeah, that also looks like a 3.8. And really, because these are right triangles, Based on the Pythagorean theorem, I don't actually need to get the third side measurement. If the two legs are the same, the hypotenuse is automatically going to be the same. But I could check it anyway. It's easy enough to kind of hold this thing up and say, hey, let me see what the measurement is. Looks like about a 7.6. And then taking it over here to this one, doing the same thing. Okay? So there are some shortcuts where you don't necessarily have to measure each piece. That one, yes, also looks like a 7.6. Based on the shape, sometimes, there's one or two measurements you won't have to take. But when in doubt, measure everything. Every angle matched up with every angle. So every angle matched up to a congruent angle in the second one. Every side matched up. So yes, these are congruent figures. Okay? And in terms of the label of this thing, if I called the first one triangle ABC, the second one, I would say it matches up with, well, A matched W, B matched X, and C matched Y. So just make sure you understand that even when you write these things, you have to match them up, okay?